Hello, everybody. We are glad to have you all on board. Today, we have Rashid and Callum with us, who will be presenting this webinar on the topic Best Practices for Multi-Tenancy in Kubernetes. We are also going to have a question and answer session at the end of the webinar. And if you have any questions for us, Callum and Rashid will be glad to help you. I hope you all have a great time, and we are just going to wait for a couple of minutes so that more people can join us, and we'll get started with the webinar. Thank you.
Hello, while we wait, so how's the weather on your side?
Yeah, summer's coming. Looking forward to it.
Sun is coming. Yeah, it's pretty poor in stock.
I think we can get started. Yeah.
Yeah, maybe we can. It's quite poor in Stockholm, So.
All right, so let's begin. Thanks everyone for attending. As Sonia mentioned, we're going to talk a little bit about Kubernetes and multi-tenancy. Who we are, so I'm Callum MacDonald. I'm Principal Software Engineer at Stakater with focus on Kubernetes and automation, CI/CD, and mostly like platform engineering type topics. And we have also Rashid.
Yes, hi guys, I'm Rashid. I'm based in Stockholm, Sweden, and been a big fan of Kubernetes since its birth. Been a developer originally. Still, I like to do development when I have time, but been doing Kubernetes for since almost 2016. Yeah, and welcome everyone. Looking forward to share with you our learnings on multi-tenancy in Kubernetes. Can we go ahead, Callum? Next step.
Yep, so the agenda today, we'll talk a little bit about what is multi-tenancy, why you want to know about multi-tenancy, some of the benefits of doing so, the personas involved, so who are the stakeholders and what are the various roles when it comes to multi-tenancy, a little bit about how to do it, some of the various models that can be followed, a small demo of a product that we develop that will make your life easier when it comes to multi-tenancy, and then the Q&A session. I believe you can write questions in the chat at any time and we'll try and answer them. Otherwise, you can wait till the Q&A session and we can answer them then. So first of all, yeah, what is multi-tenancy? I think, Rashid, you're going to talk a little bit about the what.
Yeah, exactly. Yeah, so I think it's all with the basic definition, okay, what would mean a multi-tenancy, and that is basically, you can say it's providing isolation between tenants within a cluster. And here the word tenant is sometimes can confuse people, is it who are the tenants, Is it like teams, or can we go back to the first slide, I think, yeah, on the first slide back. Yeah, so I think tenant is could it be different teams within the same organization, or it could be tenants could be you want to host different customers on the same cluster, So tenants word can be, it can be differently, based on the context, it can be defined separately. But it is you want to provide some sort of isolation within Kubernetes so that you can host different tenants within a cluster. Yeah, Callum, can you go ahead? And so basically, you are kind of logically isolating them, but physically they are integrated. So you have a same cluster that you want to share between the tenants who want to host different kind of applications within that physical integrated cluster. And it's like, yeah, go ahead, Callum. I think next step was that. Over the slide. And then the question comes, follow-ups, okay, what is a tenant, and tenant could be a set of resources that you give them, for example, a compute, storage, or like memory, CPU, and also it could be a certain set of users who want to get access to the cluster, who want to utilize or share the cluster. So that's kind of the basic definitions, of what is multi-tenancy and what do we mean by a tenant, Yeah, go ahead, Callum.
So then we'll talk about, a little bit about why multi-tenancy is a topic these days. So there's typically like 3 main buckets, I'd say, that companies care about when it comes to like working with Kubernetes, and cost is a big factor, velocity and agility, how quickly things can be shipped, and security, of course. So at a glance, typically you'd have a user that connects to Kubernetes master or the API servers, and they have some nodes in the cluster that they access. And that tenant, that user can be a tenant, it could be a team of users, it could be a product. But basically, like one tenant to one cluster is a very basic, at a basic mode. But then what happens when you have multiple tenants and want to do multi-tenancy, and it's possible to do multiple clusters, to basically use the cluster as your boundary of isolation, which is fine. But then what happens when you have many tenants, and then you start to have many clusters, and many clusters equals cost. So when each cluster has an overhead of the control plane and various components that get deployed into these clusters from the Kubernetes ecosystem to make the cluster actually usable, and more clusters equals more overhead. And it doesn't scale very well operationally when you're trying to monitor multiple clusters or keep consistency across multiple clusters. There's a lot of overhead. So basically it takes us into the concept of trying to put many tenants into a single cluster.
And Callum, when we say many tenants, so basically the idea is to share like one cluster, but have separate set of namespaces that we want to have per tenant, right?
Yes. So namespace is one of the concepts that Kubernetes ships with that provides some level of isolation, but just putting tenants into separate namespaces alone isn't the final solution. There's more that needs to be thought about there. But when we talk about like the benefits of doing multi-tenancy, the cost and the manageability is one. When it comes to the cost, so with single tenancy, a separate cluster is deployed for each tenant. Then, as mentioned, like each cluster has its own overhead of the infrastructure and all the components that have to be deployed for each tenant. If you've worked with Kubernetes a little bit, just having a vanilla Kubernetes cluster with nothing deployed into it doesn't achieve much. There's a lot of ecosystem around Kubernetes that is needed to be deployed into basically all clusters to get all the functionality that's needed when it comes to things like logging and monitoring and certificate management, and all the different bits and pieces that you want to offload from the application development onto the platform. With multi-tenancy, because the cluster is shared between several tenants, then there should be less costs for the infrastructure components, and we can attempt to lower the total cost per tenant. Also, agility. When a company starts out with Kubernetes, small and sort of doing a proof of concept, and once things are validated, then it typically ramps up very quickly. There's a lack of sort of like robust multi-tenancy architecture, which can harm like the smaller deployments, which may not be like so impactful for smaller deployments, but as things get bigger and you have more tenants and more teams wanting to onboard them, it can get quite difficult to manage, and it becomes quite evident that there's a gap there. When it comes to operations, the one cluster per tenant model, again, when you've only got a very small organization with 1 or 2 tenants, and it's maybe not such a big deal, but as things scale up over time, you start to face many challenges with managing multiple clusters. Offloading some of the cluster management onto the managed services, such as EKS or AKS, for example, can make it a little easier, but there's still, as mentioned before, once getting the cluster up is one part, then having all of the tooling and different bits and pieces deployed into these clusters is as much effort or more effort than actually deploying the cluster. And then if you're thinking about not using managed services but having Kubernetes on-premise, then deploying multiple on-premise clusters on bare metal, for example, is exponentially harder. Then there's the concept of like the efficiency. When multi-tenancy is done, right, you'll be able to be much more efficient with the resources and the time, and you'll be able to do more with less, basically. Onboarding a new tenant should be much quicker than deploying a new cluster, for example. And the common components that are in the cluster, such as the monitoring, the logging, and CI/CD infrastructure and bits and pieces, can be shared, and you'll be able to bin pack and pack things tighter on your underlying hardware or cloud resources to get more value out of your infrastructure. Simplicity, so as mentioned, managing multiple clusters can be difficult. Managing multiple tenants inside a cluster can also be difficult, but with the right tools and the right sort of approach, then we believe that doing multi-tenancy can simplify your operations and your engineering sort of abilities by reducing the number of clusters, for example, and reducing the attack surface and the burden of having to patch and maintain multiple clusters and multiple copies of the various components that are deployed to the clusters. But of course, through multi-tenancy comes with its own unique challenges. That there's a number of projects out there that are striving to solve these issues and to simplify doing multi-tenancy, which will show something that we've been working on a little bit later.
And Callum, like back to the benefits point of view, like, so which one do you think is the most important? Like, I mean, is it I think it's the operational perspective, right? Because that becomes quite a big challenge when you have to, as you mentioned, like if you have to deploy these, the add-ons, right? Like centralized logging.
Right. So that's the thing that a lot of organizations, I think, underestimate, that when starting out with Kubernetes, that they just think, okay, we can just use a managed Kubernetes service, and it's easy, spin up a cluster and off you go. But then they realize that there's many different tools and concepts that need to come into play to actually make these clusters performant and useful. A big plus of using Kubernetes is the ability to offload a lot of different functionality off your application onto the platform, but a lot of that stuff doesn't ship natively with Kubernetes. So as mentioned, things like monitoring with, for example, the Prometheus and Grafana type stack, or log aggregation using stack, or certificate management. These things aren't native in Kubernetes, and they need to be deployed and managed and lifecycled. And without doing multi-tenancy, when you're doing a cluster per tenant, then these things need to be deployed multiple times, or you need to find a solution to have this centralized, which becomes very difficult to do when it's outside of the cluster, or managing multiple clusters or servicing multiple clusters. So I think, like, from the operational overhead, it's the big thing, and the cost is the other thing. Cost of time as well as cost of monetary costs.
And what about the security aspects, right? I think they also scale up, like scale a lot, right? If you have many clusters, and then you don't know what is running on top of them, right? Like, because I also see that as a challenge.
I
That
think
if you have,
there's pluses and minuses when it comes to security and multi-tenancy, obviously. So if you're not doing multi-tenancy well, then there's security implications that tenants can potentially lead across to each other and defeat each other and impact each other's workloads.
yeah, but if they are like tenants from the same company, right? Like, so you don't have the issue of like, so you're not hosting like hostile tenants, but more like same kind of tenants.
Yeah.
Then,
so when the workloads or the code or the users are trusted, then multi-tenancy is a little bit easier because there is already a level of trust that there's not something malicious being done. And if there is something malicious being done, then you have other ways of dealing with it. For example, getting rid of those people from the organization, for example. But if you're multi-tenancy in a way where you don't 100% know, or you can't validate the code, or there's public non-controlled entities pushing code and applications into your cluster, then it's a very different topic.
right.
But we can touch a little bit on both. But there's certain controls that can be put in place to go that path and to allow not necessarily trusted workloads to be deployed. But yeah, so it depends on the use case, how much trust there is to begin with, and how simple you can achieve that multi-tenancy based on what's expected to be run in the environment. But with multiple clusters, yes, so like your attack surface is much larger. It's much more difficult to keep consistency across all of those clusters, to have insight into what's running where and control of what's running where.
Yeah, I think that's a common thing I've heard, like companies starting out with the managed services and then running up 80, 90 clusters, and then they start struggling, like how do we get a proper visibility of what is running where actually, so which can be, solved with having less clusters, but with more control. Yep, sounds good. Yeah.
So then we talk a little bit about who are the personas, or what are the different roles involved when it comes to cluster management and multi-tenancy. So first of all, we have the cluster administrators. They're the ones that are provisioning the clusters, doing the administrative work, defining the tenants and deploying the tooling and enabling the tenants to actually have some control. And then we have the tenant owners. I think we go a little bit into the details here. So as mentioned, the cluster admins provision and manage the clusters, define quotas, defining the tenants, defining the global templates, for example, building the tooling and enabling the tenants to be able to consume the cluster in a safe and effective way. And the tenant owners typically would be administrators of their namespaces. If you are able to achieve self-service, to be able to create new namespaces for the tenants without having to go through the cluster admins, and manage the life cycle of the tenant resource, and potentially be able to manage the onboarding and offboarding of their own team members or tenant members in applications. Tenant member itself typically would have some access to the namespace scoped resources within the tenant. So the tenant will consist of multiple namespaces with their products or tooling deployed into those namespaces, and the typical development team should be able to manage those namespace scope resources without in a self-sufficient way, basically.
I think the key aspect here is to when enabling this, I think multi-tenancy is how much you can do, self-provisioning, right? Like so you are able to do stuff within your boundaries without having to go back to the cluster admin.
Yeah, so when we try to ease the operational burden of the cluster admins, then doing multi-tenancy in a way that the tenants need to constantly ask the admins to create things and provision things doesn't achieve that goal of making life easier for the platform team. And so big part of doing multi-tenancy should be also enabling tenants to be self-sufficient and to be able to self-serve their namespaces, to be able to be autonomous, basically, within the cluster, and in a way that they're autonomous, but they're not at risk of breaking another tenant or even being aware that another tenant exists in the cluster. And there's various, yeah, go ahead.
No, it's good, yeah.
So there's various layers of isolation that we try to take into account when doing multi-tenancy. For example, the identity, so the tenants aren't all sharing the group config, for example, to all access the cluster in the same way. The domain isolation, which is regarding things like having the staging environment separate from a production environment, for example. Permissions, so that you have various tiers of roles, and the tenant owner, for example, can manage their tenant but can't interfere with another tenant. Resource isolation when it comes to things like CPU and memory and underlying compute resources. Storage, networking, and integration isolation, which, as mentioned, is when doing Kubernetes, you'll find that there's a huge ecosystem of tooling that you'll want to bring in and use to make your life easier, and then expanding expanding your multi-tenant concept from inside the cluster out to those third-party tools is something that would be nice to achieve. So when it comes to identity authentication, as mentioned, like just sharing a cluster admin kube config with all of the tenants won't achieve your goals there. So you need to think about doing proper user management, whether it's doing an integration with LDAP or Azure AD, for example, using single sign-on and two-factor authentication to have strong identity for the users or the developers, as well as for your services. So having proper identity when it comes to using, whether it's the service accounts on the clouds or Kubernetes service accounts, and having a way to provision these things automatically or in a self-service. Domain isolation, as mentioned, is about sort of having isolation on the different environmental and architectural layer. So whether it's various projects are isolated from each other, or system components, or whether it's the environments, dev, test, prod, they can be like your tenant could be your dev environment, or your tenant could be your test environment, and co-hosted on a single cluster. Or it could be organizational, so whether it's an organization or a department or a team or a customer, for example. Maybe Rashid, you want to talk a little bit about some of these?
Yeah, this is more like, trying to represent, like environmental versus organizational domains. So basically you have a dev environment, staging environment, and then prod environment, and then you could have different set of namespaces that want to have like team or tenant A as deploying their stuff in the different clusters. Like, so it's more like trying to represent, like how you can think about tenants, like in terms of like it could be different organizational, or it could be different environments that you can look into, right? And that's another way of looking at it in terms of like a project-based division instead of the team-based division, like a project A, which has a bunch of different microservices and different components, and then they could be deployed into different clusters or different environments. Just trying to represent, like how you can use namespaces, but then different different isolations, that you can achieve. Yeah, that's it, Callum. Yeah.
Yeah. So permission isolation, as mentioned, so there's various sort of stakeholders involved. So we've got the tenant owner or owners, the tenant members, and custom roles and are back for defining what sort of access these users have. So it'll depend a little bit on the situation, but typically like a tenant owner should be responsible for onboarding the tenant members, onboarding the namespaces, and setting up the tenant within the constraints that are defined by the cluster admins, and using the functionality that is built by the cluster admins. A tenant member is someone that we would consider that would be deploying code, deploying products into these namespaces, have administrative rights or enough rights to be able to operate their product themselves without having to depend on the platform team for operations of their product. So as an autonomous tenant within a cluster, they should be able to, well, it depends on your organization, but they should be able to manage their product end to end without having to depend on platform to help to get access and troubleshoot things. Let me talk a little bit about resource isolation. So there's a cluster is made up of compute units, basically. So you'll have CPU or GPU, memory, and these resources need to be shared. We're talking about multi-tenancy, so sharing these resources between the tenants. So it becomes important to think about things like quotas and limits, enabling the teams to be able to self-serve and provision their own products and resources, but without, for example, consuming all of the CPU available in the cluster, or leaving the other tenants without any CPU to use, or consuming all of the memory on all the nodes and causing impact to the other tenants. So ideally, the tenants aren't even aware that the other exists. They will have a defined amount of resources that is able to be budgeted by the platform teams, saying that, okay, we know we have X number of tenants and we know we have this much CPU and memory, and these tenants are allowed to consume this amount of resources, and if they need more, then we can budget for that and be ahead and proactively provision more resources using things like quotas, resource quota, and limits and limit range, for example, which we'll talk a little bit more about later. When it comes to storage isolation, it's a bit of a trickier topic. It depends very much on how storage is being presented to the cluster, but there's some things that can be thought about. For example, using storage classes to determine which backend storage a tenant has available to use. You could have different storage class per tenant that puts their data onto different backend, for example, or even just using quotas and limits to say, like, okay, we know we have X amount of storage available, and each tenant gets a percentage of that storage, and if they need more, then they can request more and we can provision more. When it comes to network isolation, so typically out of the box, when you deploy workloads into Kubernetes, there is no real network isolation. All pods in the cluster can communicate with each other, which is not ideal when it comes to a multi-tenant environment. You don't want one tenant to be able to scan the IP space of the cluster and figure out all the different workloads and pods and ports that are open inside the cluster. So it's important to by default isolate your tenants from each other on the network layer. So using network policies and being able to enforce those policies as the tenant is onboarded. So having some sort of automation in place that when a tenant is created, the namespaces are automatically injected with a default deny policy is important, so that not necessarily a default deny, but to ensure that only traffic that belongs to that tenant can traverse between its namespaces. But then you need to take into account that if you're using some shared infrastructure services, for example, an ingress or monitoring or the cluster DNS, that these things need to still be accessible by the tenants to be able to use the shared environment, but without being able to talk to each other. Then on the other layer, layer 7, so HTTP type thing, so service mesh can be very useful if you're able to do multi-tenant or multiple service mesh control planes within the cluster, a control plane per tenant, for example, so that each tenant can be also wrapped in a mesh to be able to take advantage of the additional layer of security when it comes to MTLS or the control and functionality that service mesh allows. And then mentioned earlier, so when it comes to ingress and egress, it's maybe desired. It depends on, I think, on the use case, whether it's necessary to also separate the ingress for your tenant. So you have a dedicated ingress for each tenant, for example, or sharding the ingress to avoid noisy neighbors. So for example, if one tenant is generating a lot of network traffic through the ingress or being DDoSed, for example, you don't want that to affect your other tenants. Also on the egress, so the various tenants. They may integrate with third-party products, for example, that have IP whitelisting or some other sort of need to identify themselves on the IP layer. So using something like an egress IPs or NAT gateways, for example, dedicated per tenant can help to achieve that, where each tenant is seen as unique to the outside world and not all coming from the same IP address. Integration isolation is something that we're quite interested in and working quite hard toward achieving, because we're very much aware that Kubernetes on its own doesn't achieve much, but when you bring in tooling like maybe HashiCorp Vault or Argo CD, GitLab, these various other tooling and products that may run inside your cluster or maybe shared services outside the cluster, often you need to expand that multi-tenant concept or pattern that you're using inside your cluster out to these third-party tools, or we are like for the ingress as mentioned, or DNS within the cluster, core DNS, for example, to have some firewall policies in there so that a single tenant can't resolve all the services and things for the other tenants inside the cluster. Your logging platform, whether it's the log stack inside the cluster or Splunk or something outside the cluster, to be able to expand that tenant concept out to these other tooling, will make it the multi-tenant experience much richer for the tenants, I believe. And like chargeback, so another big thing that a lot of organizations have found interested in when doing multi-tenancy is how to actually calculate the cost and distribute the cost fairly between the tenants. If one tenant is consuming much more resources than another, then if you're doing some concept of chargeback or desire to, then to be able to measure that and put a cost on the amount of resources they're using and actually determine how much that department, how much of their budget goes toward the platform, for example, and Argo CD and Vault, as mentioned before. Yeah, maybe Rashid. Yeah.
Go back. I think we're thinking like regarding these the different isolation. I think looking at the chargeback, I think here the biggest challenge is the shared infrastructure, right? If you're running a shared, let's say, logging stack or something, that becomes challenging, or right? Like, I mean, that's one of the biggest, I would say, challenge I see there. You know, how do you fairly divide the shared infrastructure when you have sharing a same cluster with multiple tenants, right?
Yeah, agree. And it depends, and I don't know if we have like a really good answer for that, but depending on the product, we're working toward building some functionality into the tooling that we are developing for doing chargeback, but it depends on the product. And
yeah, true. Yeah, good. I think moving on. Yeah, I think here's. Yeah, go ahead, Karan, please. Yeah.
Go ahead.
Yeah, I think we're going to talk about a bunch of the different multi-tenancy models that we see. You know, like it could be a namespace as a service, like having, and then as well known cluster as a service, then control plane as a service, and now there's been a new concept coming out like Kubernetes API as a service. You know, and the difference between the first two is like you have one cluster, and then you make different tenants, and each tenant has a bunch of namespaces, and then you put restrictions on what they can do. And cluster as a service is more like you run a complete cluster for each tenant, including the masters, infras, and the worker nodes. And the control plane as a service is more like a hosted control plane. So the control plane is managed, and then you can own the worker nodes. And the Kubernetes API as a service is another model that's popping up now, where you can just make the Kube API aware so that you can even create cluster level resources on per tenant, you know. So that's another thing that's coming in the corner right now.
Like vCluster.
Yeah, like vCluster, another like KubeZoo, and I think a bunch of those are coming up right now, like those stuff. Yeah, go ahead. So yes, you want to take ahead, Callum? So I think this one is more. Yeah, go ahead. I do it.
Yeah, so Kubernetes on its own is not really a multi-tenant system out of the box. There's obviously everything is shared. There is the concept of namespaces, but namespaces don't provide the level of isolation that's needed to do multi-tenancy. It's basically namespaces are there to avoid naming conflict for the most part, but also as a logical unit that you can use to target for deploying policies and targeting these to build your isolation on top of the namespace concept. Cluster resources are or cluster-wide resources are the big challenge there, because a lot of resources inside a cluster are not namespaced, and being able to enable tenants to be self-sufficient inside the cluster when scoping them only to a namespace will mean that either they have to be heavily restricted or miss out on some of the functionality that is potentially available. For example, deploying their own operators, deploying their own custom resource definitions, or hosting multiple versions of different operators in the cluster where there may be conflicts.
Callum, I lost you. I can't hear you. Can you hear me, Callum?
Sorry, somehow I got muted.
Okay.
Involves isolating some of the components. So when you have multiple teams that belong to one company using a cluster, typically soft multi-tenancy is the easier thing to grasp when there is, for example, workloads being co-hosted on the same hardware. But hard multi-tenancy is a little bit harder to do inside a single cluster. There is things that you can do when it comes to, for example, enforcing the network policies and enforcing the service mesh, and having dedicated nodes per tenant that get you closer toward being able to do hard multi-tenancy within a cluster, and this is something that we're pushing toward. So, as mentioned, we've been working on a product called the multi-tenant operator. It's currently targeted toward OpenShift. It was designed for our enterprise customers, but it will be available on raw Kubernetes, I'd say, in the near future. We're going to watch a little presentation now, which walks through some of the functionality, and I'll talk through it as we go through, and it demonstrates a little bit about how you can achieve the multi-tenancy within cluster. So here we're logged into an OpenShift cluster as a cluster administrator. We have the multi-tenant operator product running within the cluster. It's available on the Operator Hub and installed by Operator Hub in this case. It ships a number of APIs or custom resource definitions that are basically abstractions on top of the primitives that are available in Kubernetes. So we're going to talk a little bit about the tenant and the quota and the templates and the template group instance resources for now. So first of all, there was the mention of quota being quite important when it comes to doing multi-tenancy. So we want to be able to share the underlying resources with the tenants in a way and be able to control that they can't consume more than is allocated to the tenant. So with this quota resource, we're able to define, we're going to call it the demo medium quota, and we're able to define the values that are allowed this tenant is able to consume within the cluster. And these values are not per namespace, but it's per tenant. So the namespaces roll up to the tenant, and for an example here, the 5 CPUs can be consumed by, for example, 5 separate deployments using a CPU each. And if the tenant tries to deploy a 6th deployment that requests an additional CPU, then they'll be blocked and need to request an increase in their quota. That means we can do quite easily forecasting and determine how much resources are needed for the cluster based on the number of tenants we have. There's many other resources that can be set in the quota there, depending on what's available in the cluster. So we'll create that quota, and then we'll have a look at the tenant spec. So with the tenant spec, we're going to create a tenant called the demo tenant here. We're going to attach the quota that we just created. So the demo medium quota will be attached to this tenant, so that when this tenant is deployed, there'll be some namespaces automatically provisioned using the with tenant prefix keyword there, which means that these 3 namespaces will be created automatically by the controller with the demo tenant -dev and demo tenant -build, demo tenant -prod. So this is something that we would expect the cluster admins to be creating to onboard a tenant, or you may have this hosted in a Git repository and doing Git ops and have this manageable via the tenant owner themselves or a pull request, for example. But this is the part of onboarding the tenant initially. And then we've got some functionality here that we can use this common metadata field to inject annotations and labels to the namespaces that belong to the tenant. So whether they're the namespaces that have been provisioned via the tenant spec, or later, once the tenant is already created, having the tenant owner being able to self-serve their own namespaces, we can ensure that these labels and annotations are injected to all of the namespaces that belong to the tenant, and we can achieve things like, for example, the annotation there is a node selector, which means that all of the workloads that belong to this tenant will run on that specific node pool that's dedicated to this tenant. Or the label that's there, it's an arbitrary label, but we can use these labels to key off of for performing additional functionality, such as injecting or enforcing network policies, or injecting other sort of resources into these namespaces as they're provisioned. I'm a little bit ahead of the video, but let's let it catch up. So this common metadata part of, if you're a little bit familiar with Kubernetes, then everything or a lot of things can be done with label selectors and annotations, and having a way to enforce these labels and annotations on the namespaces as they're provisioned, whether they're self-served or provisioned by the controller, opens up a very lot of flexibility, basically, and a lot of use cases that can be used to build your isolation. There's 3 roles defined here: owners, editors, and viewers. We're able to assign users directly to these roles or groups. As this is OpenShift, there's a concept of groups inside OpenShift, and they can be local groups that are created either via the UI or CLI or however which way, or can also be synced into the cluster with integrations with something like Azure Active Directory, for example, using the group sync operator. So the user management can be either done inside the cluster, where the cluster admins are creating the users and beforehand, or they can be managed outside of the cluster and synced into the cluster. It's also possible, so these roles that are here out of the box map to the default roles that ship with OpenShift, but it's also possible for a cluster admins to define custom roles that you may, for example, create a custom viewer role that revokes the privileges to view secrets, for example, or to view config maps, and that'll depend on your use case or the development or the team's use case. There's also some concept of cleanup, so the on delete section there, so you can tune whether you want the tenant operator to also delete the namespaces when the tenant is deleted, or delete the Argo City application projects when the tenant is deleted, or if you have a need to retain this data, if there's persistent workloads in these namespaces, for example, you may wish to disable the automatic cleanup so that things can be kept after the tenant is removed, and maybe for legal purposes or whatnot. And as we integrate with Argo CD in this case because we're big advocates for DevOps and inside in OpenShift, Argo CD is wrapped up as the OpenShift GitOps operator, but it's still Argo CD under the hood. And the idea is to be able to replicate this RBAC model with owners and editors and viewers and the permissions they have in the cluster out also to Argo CD, so that when the development teams log into Argo CD, they're still only able to see their own apps, their own app projects, and be able to perform actions on their own product. And as cluster admins, you may want to provide like a whitelist of target repositories that these teams can sync code from, or you may wish to give them like a wildcard so they can pull from anywhere. So we'll create that tenant. And then we can see that the namespaces have been created by the tenant operator. So we have the demo tenant dev and build, and if we have a look at the YAML there briefly, we can see that there's some labels that have been created. So by default, the stakater.com/tenant label gets automatically added to the project, which identifies which tenant this project or this namespace belongs to. There's also the other annotation that we added, which is the node selector, which is on line 21, which I think I'll highlight there, which is the one that determines, so all workloads in this project will run on that node pool. And then we have also the demo tenant network policy true label there, which we'll see how that gets used a little bit after. So then we'll have a look at creating the network policies, which we'll use to target this tenant. So to deploy the network policies, we're using something called the template resource here, which is it basically you can nest any sort of Kubernetes resource inside this template. For the example, we're going to use network policies here, and we're going to call this the demo tenant network policy. And inside there's nested 3 manifests basically, which are as mentioned network policy. So basically what they do for the example here is the first network policy allows basically all the traffic between the namespaces that belong to the tenant. So it doesn't matter which namespaces this tenant has belonging to them, in this case, they'll be able to freely communicate between their namespaces, but they won't be able to, or other services outside of the tenant scope won't be able to communicate with these services on the internal service discovery, basically. So that's using that label that is automatically injected to all of the namespaces as they're onboarded into the tenant scope. Then we have another network policy there that allows the monitoring stack to still monitor or reach the endpoints for the services that may have Prometheus scraping endpoints, for example, exposed, and the metrics and things will still be aggregated into the console or into Grafana. And then the third one is to allow if they define an ingress for their workload, that the OpenShift ingress, the path of on the network is open from the OpenShift ingress to the service that's running inside the namespaces. So we'll create this one. And on its own, that template doesn't do anything. It's basically just a template, but it's not assigned to the tenant. So one way to link that to the tenant is to create a template group instance, which we'll create now. So this is very simple, but you see it has a label selector, which is where we're targeting that label that we're enforcing on all of the namespaces. So the namespaces that are created from the tenant spec automatically have the demo tenant network policy true label added to them, and we'll see as well later on that once a tenant is provisioned, then the tenant owners are able to self-serve namespaces for their tenant, and these labels and annotations will also be automatically injected, and meaning that whichever namespaces they self-serve will also have these policies applied. And the sync option there means that if someone was able to modify these network policies or this template, that the tenant operator will revert the changes and keep the state consistent. So we'll apply that. So at that point we have a tenant, and we've logged in as that tenant now, so I'm no longer cluster administrator here. I'm just a tenant member, tenant owner actually, and we can see that all we can view now is the namespaces or the projects in this case that belong to this tenant. What we can do then is, as a tenant owner, as mentioned, like with the concept that we tried to push toward, that the tenant owner is able to self-serve new projects or namespaces for their tenants, so that they can be autonomous without having to open ticket with the platform team, for example, to create new space. And we can see here that if we, the label is important. So the way tenant operator works is an admission webhook that intercepts the API call to provision the namespace, and if there is no label and you're not a cluster administrator, then it will block the creation of that namespace. So this is how we can enforce the requirement that the namespace belongs to a tenant, and that way we can enforce that all policy and the controls that are put in place to create this isolation for the tenants is there. You can also see that if we try to create a namespace belonging to a different tenant or a tenant that doesn't exist, that will also fail in the same way, or fail in a similar way.
Should we also open up for questions, Callum? Like people can ask questions like in the chat?
Yes, feel free, because I think we're getting to that time, yeah. So there we can see that the cluster owner, the tenant owner was able to create the project. There was an error there that it couldn't view the namespace, because in this example we don't have visibility of the namespaces, but we have visibility of the projects, which is an abstraction that OpenShift provides on top of the namespaces. But so then we can see that if we look at one of the namespaces that was already provisioned, that the network policies have been injected, and the new namespace that was also created after a few moments of reconciliation, that would also have the same network policies injected. So these network policies are just an example here. It could be any type of policy, or it could be any kind of, it could be, for example, a monitoring stack. It could be a Helm chart that deploys Grafana, for example. And that way you can have, as your tenants are automatically, or as your tenants are onboarded, you can have whatever resources or policies or controls that are needed to achieve your level of isolation automatically deployed to these namespaces. And here we can also see that there's a quota is available, and the tenant owner is able to keep an eye on the amount of resources they're consuming. There's nothing being consumed here at the moment because there's no workload deployed, but that way they're able to request more resources as needed. So yeah, thanks. That was a little bit of a high-level walkthrough of the basic functionality of the tenant operator, which is sort of serves as inspiration for how you can achieve that self-service while also doing multi-tenancy. Yeah, so that takes us to the end of the presentation. As mentioned, we have some time now for any questions that may be up. I'm not sure how we actually achieve that.
Yeah, I think if people have any questions, please feel free to ask. I think you have the questions box there.
Yeah, we do have a few questions in the chat there. One question we have here.
Yeah.
One question we have here is, can share some common real challenges when adding new services to clusters before it's passed to production. So I would say, like, adding new services to clusters before it gets to production. So when you're deploying things to production, to non-production, one of the big challenges is to be able to do that in a fast and effective way. And I think maybe Rashid, you can talk really quickly on the inner loop versus outer loop part there. And for example, being able to deploy things to sandbox or staging type environments via pull request or before getting to production. I think that touches a little bit on that question. Can you elaborate on that a little bit, Rashid?
Sorry, Callum, I was looking at can you repeat, what was that? Sorry.
Sharing some common real challenges when adding new services to a cluster before it gets to production. So, and I think the inner loop, outer loop concept that you're quite
yeah, exactly. Yeah, I think the inner loop and outer loop, exactly. So I think that's definitely very helpful. Like if you are looking into how to do, like if you guys have looked into some inner loop tooling like Tilt, or I think called Tally Presence and those kind of things, you guys can look into that. And they're really helpful for you to do faster local development and validation towards your clusters, and so that challenges ahead. But I think it's a quite wide topic. If you have something specific, I mean, please ask, and try to answer.
Yeah, the next question. Yeah, there's another question that's kind of interesting. So Arnie asks, regarding storage isolation, customers are companies that use our software to store information about their employees. If the customer stops their engagement, I want to be able to delete their data and backup. Can that be handled with multi-tenancy? So going from the example of the tenant operator, for example, where I showed that it has the functionality to do automatic cleanup. So if a customer is no longer using the product and no longer paying, and you remove that tenant from your cluster, then if you've got some sort of concept of automated cleanup where you delete the persistent volume claims and have using the configuration in Kubernetes to also automatically delete the underlying persistent volumes, could achieve that. Or it depends on where this data is being stored. If it's being stored outside of the cluster using something like S3 or EFS or something that's not necessarily a native persistent volume claim, then you would need to think about how to build that automation into your multi-tenancy. I think a big point here is doing multi-tenancy, you need a lot of automation around it, because doing everything manually and having the cluster administrators having to manually create namespaces and manually create the roles and the role bindings and manually provision all the different network policies and things will be just as hard, if not harder, than doing cluster per tenant. So building the automation or leveraging the tooling that's out there on that various different organizations are building around this multi-tenancy concept will make it much easier and much more robust. So if deleting...
To add here, actually, I think it's, again, as Callum mentioned, I think this is one of the points that we had under integration isolation, because if you, let's say, using an open source solution like Valero for backup and restore, Valero doesn't have a built-in support for multi-tenancy, but I know there's a feature request out there. But there are some other vendor products that have multi-tenancy in their backup restore. So you can do it like when you have a tenant can create their backups, and then you can define the policy that should their backups should be kept or not. But again, if the data is so low level that if it is something within the backup, I think then it has to be solved somehow differently. But if it's just one backup for a tenant that should be removed, I think that can be done, can be achieved. But again, you will have to build automation, because I think that's one of the things we have learned, that we can achieve multi-tenancy in Kubernetes, but since we have to deploy so many things on top as well to get towards a better complete platform, you have to do further integrations, with Argo CD, with HashiCorp Vault, and with, let's say, Valero or image registry, and then you can control the whole thing, like do you want to delete when the tenant is deleted,
Yeah, and that's something we're trying to achieve with the multi-tenant operator, that it performs the multi-tenancy inside the cluster, but the way it's been built is to be extendable using a plugin model, so that companies that are using it, we will provide plugins for common things that we see value, for example, the Vault and the Argo CD. But the idea is that we won't be able to cover all use cases. So if an organization is using Splunk or some other GitLab or GitHub even, that they will be able to build their own plugins to extend that tenant definition out to these third-party APIs. And they'll be able to easily extend the tenant operator with the functionality that's needed to achieve various use cases that aren't coming out of the box.
Good.
Another question here from David. You said tenant operator might soon be available for vanilla Kubernetes. Do we know when that will be approximately, when it will come at a cost? So originally tenant operator, our one was built for OpenShift, and it was built using some of the OpenShift abstractions that aren't available in native Kubernetes, for example, the project abstraction and the native groups abstraction. And so there are some challenges that we need to deal with to make it run on vanilla Kubernetes. But yes, it's something that we're prioritizing highly, and we hope to have it available within the next, I'd say, like a year until it's like GA, I'd say. But it's a work in progress. Whether it will come with a cost, I think, yes, typically we will do a free tier where you'll be able to manage, say, 2 tenants free, but to have the enterprise support and to be able to use it unlimited will be at a cost. That's, I think, the current plan anyway. And then the last question that we have there, not a great question, but will a recording be available? Yes, I think it will be. I believe you will receive a follow-up email that hopefully will have details about how to access the recording. I may be wrong there, but that's my sense.
You're right, Callum. That's how it works.
That's how it should be anyway.
Yeah, that's how it should be, right? That's how we assume things should be done, right? Awesome. So
cool.
great.
So thanks for the questions. Thanks for the attendance. Hopefully we touched on some topics and give you something to think about. And yeah, as I mentioned, there will be a follow-up email, and we're more than happy to continue this discussion and go deeper into some of these topics. We're very limited on time now, so it's a little bit hard to go really into the technical weeds, but we're more than happy to do so. So if you want to talk more, then please respond to the email that gets sent out. Otherwise, thanks, and everybody, and have a good day.
Yeah, good, guys. Thank you very much. Bye-bye.